Yep. So, Hosein, are you happy to present now?
Yes, of course.
Sorry. Okay, wonderful. Okay, so we will move ahead. Okay, and so over to you. So you're going to be presenting on the hidden tax of EPA enforcement actions, evidence from electricity markets. And the discussant is Peter Gibbert from Otago.
Okay, just...
So you have half an hour from...
It's great. Okay, thank you so much. Thank you. I want to, at the beginning, I want to thank you for accepting my paper and giving me this opportunity to present my paper over here. Actually, I am a PhD student in finance at Schulich School of Business, York University. And as you can see over here, this paper is titled "The Hidden Tax of EPA Enforcement Actions: Evidence from Electricity Markets." So to start, I want to raise this question: why electricity sector, and what is specifically important about this sector that makes it worthwhile to study? As you can see over here, this sector is responsible for a significant amount of emissions in US, specifically CO2, SO2, and NOx. They are among the most hazardous and most important byproducts of burning fossil fuel. In 2001, for example, the electricity sector was responsible for emitting more than 37% of CO2, 74% of SO2, and 56% of NOx. Actually, the level of emission decreased drastically until 2019, but still in 2019 and now, this sector is responsible for a huge amount of emissions. So this is the case, and due to the importance of electricity sector, EPA has came out with several different regulations to limit the amount of emissions in US. Specifically, following the amendment of Cleaner Act in 1990, EPA introduced the acid rain program. This program was designed in order to reduce emissions of SO2 and NOx in the power sector. And looking at this graph, you can see that the green line is for NOx and the red line for SO2. You can see after 1990, the level of SO2 and NOx emissions in US decreased considerably. So it seems that these types of regulations has been fairly effective, but without having proper monitoring and enforcement, no regulation can be as effective as we expect. So this is an essential part. So at most, without having proper monitoring and enforcement, all these types of regulations would not be nothing more than some benign recommendations. Actually, this is what EPA is doing. For example, in 2021, EPA has spent more than $2.5 billion in environmental programs and management, which led to more than $8.5 billion of commitments by different violating power plants in order to come back to compliance. So having this in mind, these are the research questions that I want to explore in this paper. The first question is that how effective is environmental enforcement and monitoring in reducing emissions, and whether the efficacy or effectiveness of these enforcement and monitoring depends on organizational structure of utility firms. The second question is that whether the effect of the monitoring and enforcement is very local or it propagates through within the firm network of establishments. And next, I will tend to study what is the impact of reduction in emissions on production costs, and specifically fuel costs in power plants. And at the end, if these reduction in emissions increases fuel expenses, whether these expenses, these higher expenses associated with less emissions are passed to ultimate customers by increasing electricity prices or not. And in the last part, I will see what are the mechanisms through which power plants manage to reduce emissions, and what is the underlying reason for the propagation of enforcement effect within utility firms. So this is pretty much the outline of what I want to discuss in the remainder of this presentation. There are a couple of data sources that I use. They're mainly from two major sources, EPA and EIA. I get emissions data, non-attainment versus attainment status of counties, and the enforcement actions data from EPA, and the operation, the characteristics of power plants and different operational decisions from several different data sources from EIA. The sample period starts from 2001 and it ends in 2020. Actually, in this paper, I only focus, I actually drop or exclude the publicly owned utilities or those power plants that have missing emissions data. So this is pretty much this setting. So the first thing that I want to see is that what is the direct effect of enforcement actions? By direct effect, I mean the effect on power plants that receive an enforcement action. To test this, I use a stack definitive regression. I focus on an 11-year period around those events. So in this setting, the treatment group consists of plants that receive an enforcement action. If one plant receives more than one enforcement action, I only focus on the first one. And the control group consists of plants that are located within 100-kilometer radius around the treated one, but they are neither themselves targeted by EPA, nor any of their siblings receive an enforcement action. By sibling, I mean other plants that belong to the same parent utility firm. So this is the setting. I run this regression on a couple of outcome variables. So in the first three columns, I find that following this enforcement action, targeted plants reduce emissions of CO2, SO2. Specifically, emissions of CO2 is decreases by 38%, SO2 it decreases by 45%, and NOx by 28%. Next, in column 4, I look about the total production or total electricity generation in those plants. It seems that the amount of electricity that they produce or they generate, it decreases significantly. So when we see that the amount of generation or production decreases, there might some question might comes to mind that whether they are reducing emissions in order to, or instead of that, they are increasing emissions or generation in other plants that are not directly targeted by EPA. So if there is such an emission leakage hypothesis, we would see that the plant share would decrease. What's the plant share? The plant share is defined as the total generation in the focal plant divided by the total electricity that is generated in the parent utility firm. So, however, we don't find any significant change in plant share. It suggests that there is no evidence of emission relocation within the utility firm's organizational structure. Next, in the last comment, I actually test what is the effect of these enforcement actions on fuel costs. By fuel costs, I mean the dollar value that utility firms spend to get a unit of heat. So the results show that following enforcement actions, the power plants, directly targeted power plants, they incur about 16% more to get a unit of heat out of fossil fuels. So this is pretty much the direct effect on power plants that are directly targeted. The next question is that whether the efficacy of these enforcement actions depend on the organizational structure of utility firms. In order to test this, I divide the sample into two subsamples. The first subsample consists of single plant utilities, utility firms that have only one operating plant. The second subsample consists of plants that belong to a multi-plant utility firm. It means that they have that utility firm has at least one power plant operating in other regions. So as you can see over here, the effect, there is no effect actually for single plant utilities, but the effect, the reduction in emissions, the reduction in generation, and the increase in fuel expenses exist among multi-plant utilities, specifically in plants that belong to multi-plant utilities. So it suggests that somehow the efficacy or effectiveness of these types of enforcement depends on organizational structure of utility firms. So the next question is that whether the effect of these enforcement actions are confined to direct targets or they propagate through network of establishments. In order to explain that, let me have a hypothetical example. Imagine there is a utility firm A that is operating in Texas. So this utility firm has 4 different plants. Then, for example, one of them, plant A1, is targeted by EPA and receives an enforcement action. I want to see what happens to the other 3 plants that are not targeted by EPA. What happens to them? So in order to do that, after the enforcement action in this plant, these 3 other power plants would be considered as control group, as a treated group. And the control group consists of plants that are located within 100-kilometer radius around treated ones. So the identifying assumption is that within small geographical areas, so the identification assumption is that these plants located in small geographical areas are expected to be similar in all different, plausibly similar in all different dimensions, except their exposure to environmental enforcement through parent establishment network. So this assumption seems maybe plausibly, it seems plausible because of the local nature of electricity market, the structure of the electricity market, and the price of electricity is very local. More than that, the exposure of plants that are located near each other in a small geographical area to environmental regulations it is not expected to differ materially. So they are exposed to quite the same level of environmental stringency, etc. And more than that, the fuel procurement options or fuel costs, it is not expected to differ materially within small geographical areas. So this is pretty much the identification assumption. In the test, sorry about that. Yes, in the test, I run the same stack different regressions. I have the same 11-year period around events. In this regression, all plants that receive an enforcement action are all excluded. Treated plants would be those that receive an enforcement action in one of their siblings, and control group consists of plants that neither themselves nor any of their siblings receive an enforcement action throughout the sample period, but they are located within 100-kilometer radius around treated ones. So the outcome variables that they test are the same as before. as you can see over here, the level of CO2, SO2, and NOx emissions decreased significantly following enforcement actions. The level of electricity generation decreases as well, but the plant share doesn't change significantly. So it suggests that there is no emission leakage. And at the end, we can see that fuel expenses or fuel costs increased by 28%. Or no. Yeah, it increased by 12%, by about 12% following those enforcement actions. So this is the direct effect, but there might be still, although in these regressions I control for cohort times plant fixed effects. So these fixed effects are expected to capture all time invariant plant characteristics. And I focus on a small geographical area to minimize the confounding factors. But there might still be some concerns that there might be some time variant characteristic, utility thermal plant characteristics that are driving the result. To address those indigeneity concerns, I use an instrumental variable approach. In order to be valid, my instrument needs to be correlated with the indirect exposure of plants to environmental enforcement, but it should not be, it should be exogenous to plant level operational decisions. This is how I calculate my instrument. For example, the instrument for this plant over here, plant A2, I don't know if it is too small or not, but this plant over here that I'm showing, at first to calculate the instrument, I drop all plants that are located in the same county. They are all excluded. Next, the value of instrument would be equal to the ratio of plants that are located in non-attainment counties. So for example, if these two are located in non-attainment counties, the value of this instrument would be 2/3. So this is pretty much the instrument and how I define or calculate that. To be valid, it should be relevant. And there are a couple of researches that show those plants, or generally those firms that are located in non-attainment counties, they are subject to more stringent environmental regulations. As a result of that, they are more likely to violate environmental regulations and receive an enforcement action. So if the value of instrument is larger, that plant is more likely to receive an enforcement action in one of its siblings. It satisfies the relevance condition. And about the exclusion condition or restriction, the attainment status or non-attainment status of other counties that the utility firm has a plant over there doesn't seem to be directly correlated with the production decision or operations of the focal plant that is located elsewhere. So this is actually the exclusion restriction. And having this IV, I run the 2 SLS regressions. The first column is the result for the first stage. The F stat was considerably large, and it rejects the null of having weak instrument. And using this IV, I have the same outcome variables. The results show that the reduction in emissions, the reduction in electricity generation, and the increase in fuel expenses seem to be robust to indigeneity issues. So far, I showed that these are...
Just to say you've got another 5 or so minutes, yeah?
Okay, thank you. So far, I showed that these regulations are effective in terms of reducing emissions, but the reduction in emission comes at the cost, and that is the increase in fuel expenses. The next question is that whether these costs are passed through to customers in terms of increasing electricity prices. I have two subsamples, one for single plant utility firms and panel B for the multi-plant utility firms. And I have three electricity price variables: retail price, wholesale price, and average price. The results show that there is no effect for single plant utilities because they don't react, but the prices for multi-plant utilities increase significantly. Specifically, the wholesale price of electricity and the average price of electricity is becomes higher following enforcement actions. Then I have a cross-sectional test that I study whether there is any differences between regulated versus non-regulated utility firms, and I find that the most of the results happen in regulated utility firms. Then I want to see what is the mechanism, what are the strategies that power plants use to reduce emissions. Actually, I test how different fuel inputs, fossil fuel inputs, change following enforcement. I find that directly targeted plants reduce using coal, and as a result of that, they increase their reliance on natural gas or generally gas. Also, I test what happens to the total sulfur content of fuels, and I find that the sulfur content of fuels decrease significantly. This was for directly targeted plants. For indirectly affected plants, it is pretty much the same. They reduce using coal and petroleum, and their reliance on gas increases. The sulfur content as a result of that, the sulfur content of fuels decrease as well. Also, in order to change fuel, there might be some cases that plants need to change the type of generators that they use. I find that usually those plants that are targeted by EPA, they tend to increase their generators, and specifically combined cycle generators or gas turbines, which are the type of generators that rely more on natural gas. So this is consistent with the previous result that I had about fuel mix. And at the end, I want to see what is the underlying reason for the propagation of the enforcement effect. So the first thing that they measure is that the economies of scale in terms of fuel mix changes should be one reason. I create a fuel mix similarity between the targeted plant with other siblings, and I interacted with the post and treated dummies. I find that the fuel mix similarity with sibling, it doesn't matter for directly targeted plants, but it matters for the propagation effect. So the higher the fuel mix similarity, the more reduction, the stronger propagation. Also, I test what happens if those plants change fuels, whether the changing in the fuel depends on presence of the same type of fuel in other siblings. I find that for directly targeted plants, it is not necessarily the case. The change in fuel mix depends less on presence of those fuel in the siblings, but for indirect effect, it matters a lot. It seems that those siblings, non-targeted siblings, tend to react more when they have the same type of fuel as the targeted ones. So, and I have a couple of cross-sectional tests to see the heterogeneous response of different power plants. I found that I test the concentration of generation within utility firms. I find that directly, it doesn't matter, the concentration doesn't matter for directly targeted plants, but the propagation effect is weaker if the utility firms are more concentrated. I test the effect of distance between the plant that is targeted and other siblings. It shows that the effect is stronger when the distance between these two groups of plants is smaller. I test at the age of power plants, it seems that the effect is stronger for older plants. And at the end, I test whether the regulatory status of power plants or utility firms matters. Previously, we showed that mostly regulated utilities can pass through costs. Over here, I show that both regulated and non-regulated utilities react and respond to enforcement, but only those that are regulated are better able to pass costs to ultimate customers. So that's it. It is pretty much what I had to present. As to conclude, I showed that environmental enforcement is quite effective, especially among multi-plant utility firms. Those enforcement increase fuel expenses, and the higher fuel expenses are at least partially passed to ultimate customers. And economies of scale seems to be an underlying reason for the propagation of environmental enforcement. That's it. Thank you so much for your attention.